We're given dy over dx equals 4x over 9y. If I were to plug in 0, comma, negative 2 in for dy over dx, I would get dy over dx is equal to 4 times 0 over 9 times negative 2, which would be 0 over negative 18, which is 0. So dy over dx is 0, but now we want to see the second derivative. Is it positive or negative? Well, for that, we need to differentiate 4x over 9y. Okay, so this is dy over dx is equal to 4x over 9y. We're going to take the derivative with respect to x to both sides. So that means we'll have the second derivative. And now we need to take the derivative of 4x over 9y with respect to x. This one we have to use the quotient rule. So first take the derivative 4x, multiply that by the denominator, minus take the derivative of the denominator, and this one will be 9 times the derivative of y, which is dy over dx, or you can just put it as y prime, times the top is 4x. And then the denominator, we have to square 9y to get 81y squared. So we simplify this. We have 36y minus 36xy prime all over 81y squared. So keep in mind, y prime dy over dx we said is 0. That's from this over here. So this whole thing would just be 0. So we'll be left with 36y over 81y squared, which I can divide top and bottom by 3. Or actually I can divide top and bottom by 9. I get 4, and then divide by y over 9y. Y is negative 2. So if I plug in y equals negative 2, I get 4 over negative 18, which is negative 2 over 9. Okay, so the second derivative is negative. So that eliminates a bunch here. So we can eliminate A, we can eliminate C. Now, if the second derivative is negative, then that means it's concave down like this, and it looks like a maximum by the second derivative test. So this would have to be a relative maximum at 0, negative 2.